In this tutorial, we are going to go over your keyboard control lab exercise. Oh, and just as an aside, I want to mention this terminal multiplexer I use. It might be beneficial for those of you who haven't heard of it. On the screen right now, I have 4 terminal pins through which I have SSH'd into the car. It gets rather cumbersome to operate a bunch of separate terminal windows. To avoid the clutter of so many different windows, I prefer using either Tmux or Terminator. The one you are seeing in this video is the Terminator application. The terminals become a lot easier to manage and view. Anyway, back to the tutorial. I am going to walk you through your lab exercise, wherein you are asked to control the car with your keyboard. This video will make full sense to you only if you have read the accompanying description of the lab exercise. I'll talk you through the different nodes that you need to run and also the importance of each of them. Let's start by going into our workspace and sourcing the environment. Once we got our environment set up, we begin by launching ROScore. We now run the talker-im node. This node is waiting for the desired throttle and steering from the user via the teleop praxis node. We next start the ROS serial node, that is the teensy. Use the ROS serial command to launch the node. We now run the teleop praxis node. The zero throttle and the zero steer refer to the 15% duty cycle that was mentioned in the write-up, where the car is oriented straight and is stationary. Notice also the corresponding value of 9830 that is transmitted by the talker-im node to the teensy. Refer to the lab handout to see how and why we get a 15% duty cycle with 9830. The range of user input in this implementation is limited to -5 and +5, which corresponds to 10% and 20% duty cycle respectively. Again, refer to the lab handout if you aren't sure why these thresholds of duty cycle are important. We will now command the steering through the keyboard. The same type of control holds good for throttle. You can see that I have chosen the incremental step to be in the order of 1% duty cycle. This is something you can take a call upon in your implementation. Also, I have made my control to be such that the value of a particular command does not go back to 0 if the key is unpressed. These are just design choices, and you could implement it in whatever style you prefer. Remember, you also have the option of doing this in Python. Refer to the documentation for related links. There are a lot of opportunities to be creative in this lab, and we hope you guys enjoy.